First thing we learn as kids in math is how to count, and I think most of us use our fingers. I might have to have a... I'm writing, I can't use my fingers for it. Show me one finger. Two.
Alright, so if you said,
How did this one? And 5, and 6, and 7, and 8, and 9. I just want to make sure you know your numbers. Okay. Okay, so here we have 75 marks according to our normal. If you want to check, it's 5 times 15. That's 75.
Do math in this club?
Yeah, we do math in this club. Did you know that? So we have 75, but what does that actually mean? Well, it means this many of something. And how do we get to this? Well, we start at hands.
and then
0.
that can, what can that
And
help
we
you do?
keep
It can help you
counting.
get things done.
So we have 0,
Get work
and we go through 1,
See what I'm doing here?
2, face the audience.
Okay,
my goodness.
and it can help you.
Thank you. 3, 4,
I think you can understand from what he's saying how much to put up.
6.
There you go.
There we
And then
go.
what else helps, what
7,
else is organized?
8, 9, and then, oh crap.
What else?
We're out of symbols. Now what do we do? Well, we could make up more and more and more symbols. So maybe a star will represent the next number.
Okay, well, let's
A smiley face will represent the next number, and then Chuck Norris will represent all the rest of the numbers. But that's not going to be very helpful to us after one more finger.
So why don't you,
Can you make a face out of Chuck Norris?
Oh, we can.
Just do a Chuck Norris impression with your face.
Look at
That's all.
that for some of these.
Next map.
Yeah, this is what we're going to do.
Okay,
Why don't you
so-
give me a T-chart
This seems tedious because
of,
Americans usually can't memorize more than about
you want to just
10 things.
use the back, that's fine.
Because we have 10 characters here. We could just say, show up your hands of 10. We have, let's just say we have one set of, I don't know, let's call it a unit of something imaginary, something super cool, imaginative, I don't know, let's say
I mean,
10.
this is.
So we now have one set of 10 plus, and how many single ones do you have left over? And plus 0
I'm
ones.
gonna move over to my desk, okay?
Is it any
Let me check on.
coincidence that these are called digits and so are these? So we might put these together and write it like that. And we would go through. We have 110 so far plus another 1. And then we have a 2. Just don't show that. So we have one, we know we have 110, 2 1s, 3 1s, 4 1s, and so on and so forth until we get to this point. And if we add another finger, we now have a new set, another 10. And that's just, it just continues cycling on and on. After a certain point, we get to this number, which means we have 9 10s and 8 1s. We add 1 onto that, and then we say, okay, one more. Cool, we have another set, but that means we have a set of sets. So we're gonna have to come up with another thing. So let's call it something cool. Hey, what do you think we should call it? Maybe 100? Yeah, I think it's lame. Let's see what it is. So if we just keep counting like that, maybe we'll end up with a number like 541. And what does that number actually mean? Yeah, good luck. What does that number actually mean? And we know, because we're used to this system, this would probably mean, let's start back. We have 1, 1. We have 4 10s. And we have 5 hundreds. Which, how many 1s are in a 10?
10.
And how many 100, I mean, how many 1s are in 100?
100.
Or the 10 10s and 10 1s, so 10 is a 10 squared. So the first, and anything to the 0th power is 1.
Mm-hmm.
So this number means 5 times 10 to the square, 10 to the 2, plus 4 times 10 to the 1, plus 1 times 10 to the 0. Kind of tedious because we already know that number system pretty dang well. We use it pretty much every day of our lives. How many people can tell me what their age is in this?
Well, not entirely.
I'm pretty sure you're 17, mister. And
If you put a gun to my head, I could probably do.
hope we don't need to resort to violence in this room, but
Well, you've already got a holster.
this is true. So the idea is that I just want to be really general here to help you understand this a bit better. Imagine if you had an alien come in, and he, instead of having 5 fingers on each hand, had 8. For a total of how many fingers on 2 hands? 16 fingers. Which means, in addition to our super cool numbering system, if we wanted to be like that,
Chuck Norris.
it would go up to Chuck Norris. Actually, maybe not. So we'll go, we need to add 6 more characters. First 6 characters I can think of are alphabet letters.
So now aliens with 16 fingers
We
use
have
hexadecimal.
Yes, we have 16 characters. Notice these are in powers of 10 because there are 10 digits, 10 different possibilities. So just like we used to count here, we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Instead of going to a 10 and a 0, ones, we keep going. A, B, C, D, E, F. And after that point, if you want to add one, you now have a, it's not really a 10 anymore, we could call it a set, I suppose. 1 set plus 0 ones. Which doesn't represent, which would you write as this, but that doesn't represent 10. It represents 1 set of 16. So if you keep going, you go 1, 1, 1, 2, 1, 3, 1, 4, dot, dot, dot. 1, 9, 1, A, 1, B, 1, C, 1, D, 1, E, 1, F. You now have a new set if you add 1 more. So you now have 2 sets of 16. And you just keep going. If you got to 99, what would be the next number?
It would be
It's kind of a trick
9A.
question. 9A. It wouldn't go to 100, it would go to 9A and keep going 9E, such and such. The equivalent would be, however, if you get to F. Add 1 more to that.
Then you have the 1, 0, 0.
1, 0, 0, because you have a full set of 1s, which adds 1 to the set of the 16s, which means you have a set of 16 16s, which I don't have a name for that. I'm sorry, I don't have that off the top of my head. So we'll just call it a bunch, 1 bunch of stuff. So if we have the number, something similar to that, but not quite the same, 5B, oh, right, 5B1, what would this be in terms of this?
So that'd be
Instead of times 10s, we'd
it'd be
times
times
powers of
16.
16. So we have 1 times 16 to the 0 plus B times 16 to the 1 plus 5 times
16 to the squared.
16 squared. And if you get your calculators out, somebody get them out. This is not supposed to tell loud now, right?
So B is equivalent of
B is equivalent of
12?
9,
Or no,
10,
11.
11.
11, okay, so that's... So it's
Distract Christian some more.
yeah, that's a significantly bigger number.
So much larger number. What'd you get?
1,457. Or excuse me, yeah, 57, right.
We'll call that dec or decimal. This is, as someone brought up, hexadecimal because it has 16 things, hexa and dec, 16. Now, what if we ran into the opposite problem of, we don't run into an alien with more fingers yet, and run into an alien with almost no fingers. In fact, he only has 2.
Oh, yeah.
Or, yeah, so, or we can, with it in a bit more familiar form, maybe you've seen these involved in computers. This is binary, because bi comes from, of course, the root for 2. Because you only have 2 options, 0 or 1. In computers, it's either on or off. Until when you find a way to make a computer recognize slightly on or slightly off, let me know. You will probably be a huge
Now, go ahead.
genius with many monies.
Start writing.
Let me know if you can get some to me. Okay, so with binary, we'd start at 0 just like we normally would, and we'd go to 1 next just as we normally would. But now we have a full set already. So we have 1, 0. We have 1 set of 2's.
Wrap it up and give it.
And then we want to add 1 more. That's fairly easy. But if you want to add 1 more to that, you're going to add another set, which is going to fill that out and then get a 3-digit number. And it keeps going like that. Add another set. It becomes big very quickly, which is why you need a number this big to represent that number. So, looking at, say, this number, actually we'll do something slightly different so it's not quite as confusing. Actually, that would be even more confusing. We'll do that. What does this represent in decimal? We're now working with powers of
2.
2. So we have 0 times 2 to the 0 plus
1 times 2, or just, yeah, 2 to the first, plus 2 to the second, plus 2 to the third.
which is
Yeah?
So 8 plus 4 is
Oh, no, I got that.
2. So 14, yeah.
I skipped 8.
Now you can do this with pretty much any number for your base. You can do it in, I've seen it done in 8, which is octal. You can see that.
Yeah, Grayson was talking about that, how some people were, instead of using their digits, they use a space in between their digits on their hand, so they would use the 1, 2, 3, 4 spaces, 1, 5, 6, 7, 8.
You can even do hexadecimal on your fingers too. It's the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. I think I missed a 0 in there, sorry. So, but what I think is interesting between these two is, what if we, in binary, often you will see digits split up into 4s, just like you see in normal decimal, be like 1,237, it's split up with that comma. Binary, which is usually an 8-bit or a byte, I think, right? And these segments are usually split up in half, and the interesting thing is, what is this in decimal? Just this 0, 1, 0, 0. What?
Oh,
What number is this?
eight.
No. Because this would be 1's place, 2's place, 2 squared, or 4. So 1, 0, 0, or 0, 1, 0, 0 is 4. Does that make sense?
Oh,
Mhm.
just that part.
Yeah.
Just this part. Yeah.
I thought that you were
Sorry,
counting
no,
the
just
entire
looking at
part,
this
which is-
part.
The whole-
No,
the whole-
just look at this part.
Okay.
Okay. So,
11?
yeah, 11.
Which in hexadecimal is called E.
Ah,
See
the
the
4B.
resemblance here.
Now I get it. Yeah.
So the first digit of hexadecimal gives you the first 4 digits of binary, and the second digit of decimal gives you the second 4 digits of binary.
First,
Which means you can write computer stuff in much shorter ways to describe things. And I know colors on the computer are usually written as hexadecimal because you can have 2 bits, one for red, 2 bits for red, 2 bits for green, and 2 bits for blue, I want to say. And those things can combine to make all the colors that we know of. Doesn't really matter to me, I'm colorblind. So, that's what I think is really cool about these two, is that they're related in that way. If you want me to, I could talk to you all about base 12, which I think is my favorite base, but I'll get to that later. The important thing, I think, is that in math, sometimes we get so caught up in the numbers that we forget that it actually means something. And that all these 3 things all mean that many stuff. This many dollars, this many dogs, this many Tyrannosaurus rexes eating this many Triceratops. I don't really know what else. But numbers don't necessarily have to be in that way, and they can be creative with math and write things the same thing in many different ways. As someone once said, poetry is calling the same thing different things, and mathematics is calling different things the same thing. So, no matter how you write your numbers, doesn't really matter. It's what it represents that counts.